Okay, let us discuss the next problem. This is a very good problem. So problem number 1.65. So this is 1.65. So let me read. A plank of mass m1 with bar of mass m2 is placed on it. So I have a plank. So let me first make the diagram. So this plank is mass m1 and there is a block that is kept above this. This is mass m2 and this is further kept on a smooth plane. So let me read. So this is placed on a smooth horizontal plane. So this is mu is equals to 0. Are you getting? Now what the next says, so a horizontal force growing with time as a function F(at) is applied to the bar. So there is a force that is applied on this bar. So there is this bar or object, or you can say this is a plank, this is a bar. So this one is plank, the lower one is plank, and the upper one they are calling as a bar. There is a force that is applied on the bar, and this force is a function of time at. If time is equals to 0, this force is 0. If time increases, so force linearly increases. You see, force is at. So force is variable. So this is a variable force. So this is this depends upon time. So this force is basically a variable force. Now what this is next, find how the acceleration of Planck 1 and Planck 2 depend upon t, and oh my god, friction coefficient is given k. So the friction between Planck and the bar is k. So there is a friction, this is not a smooth, and friction coefficient is k. So there is a friction, so this surface is rough. So let us make this rough. So friction coefficient is given and this is k. You have to find, so what we have to find is, we have to find what is the acceleration of 1 and acceleration of 2 with as a function of time. So I have to find what is the acceleration of 1 and 2 as a function of time. So how we will proceed, you see, when time is very small, this force that is t equals to 0, this force is very small. Gradually this force increases, so this force is increasing. But as soon as this force increases, there is a friction force also. So initially what will happen, this block and this block, both will move together. Did you agree with this point or not? Let me know. You see, initially there is a friction force. This friction force is very small, and this friction is also small. This force is also small. If you grow this force, this friction force will also grow, but up to a certain limit. After a certain point of time, this friction force will not grow because this is a static nature. After some time, there will be kinetic friction will start. So this force is again, because this is increasing, so this force will keep increasing. Now what will happen? This friction force will become constant and this force is again increasing. So now this block will slip over this. Are you getting? So friction force initially, you see, so what I am saying, so friction force initially increases, friction will increase, also F will increase. Did you agree? F will increase. But after some time, friction will have a constant value. After some time, friction will have a constant value. So now if friction is a constant, at this point of time, what will happen? This force keep increasing and this force is constant, so this block will slip. So at this point, slipping will start. Slipping will start. This is an important point. Before that, there is no slipping. Let us call this time as T0. So before T0, there is no slipping. So let us say the slipping starts at time T0. So T0 is the time when slipping starts. So this means before T0, so I say if T is less than T naught, let us situation 1. If T is less than T naught, both blocks are moving together. Both blocks are moving together. Did you agree? So what is the total force on the system? So this friction force becomes internal in nature. So total force over this system is F. Are you getting? And what is the mass of system? m1 plus f2. So I can reply force is equals to mass into acceleration. m1 plus m2 into acceleration. So acceleration will be F divided by m1 plus m2. And F is given by A into T, so I can write A into T divided by m1 plus m2. Up to this point of time, you see both blocks will move together, so both blocks will have same acceleration. So I can say acceleration of 1 is A1 and acceleration of A2 is A2. So both blocks will have same acceleration. Are you getting or not? So let us call this as any variable I can choose. So let us choose omega 1, that is or W1. The acceleration of block 1 is equals to acceleration of block 2, that is W2. This is equals to acceleration, total acceleration, or that is the A we have calculated. So, or you can call it a W. Are you getting or not? So if I call it W, so total acceleration, this is AT by m1 plus m2. So up to this point of time there is no slipping, but after this time there will slipping will start. Are you getting or not? So what will happen? So if T is greater than T naught, now slipping will start. Slipping will start. Basically we can find what is the time. So what will happen now? You have this block. This block and this block will move separately. This block, on this block I have a force F, that is equals to AT. Now there will be a friction force, that is, now normal reaction is M2, so this is M2, this is M1, so normal reaction will be M2 into Z. I assume that you understand, because normal reaction on this force is equals to M2Z, so I can write friction force is Km2Z. Did you agree? Newton's third law, if this is applying a friction force in this direction Km2Z, so I can apply a friction force on this blocks in this direction, that is Km2Z. Now see, let us say acceleration of this block is A1. So lower block is going acceleration of A1. Now the upper block has acceleration of A2, but this with respect to M1. So this is A2 acceleration with respect to M1. So block 2 has acceleration of A2 with respect to M1. So this means now this becomes a non-inertial frame. So on this block I have to apply a pseudo force. If I want to write equation, so I will write M2 into A1. This is a pseudo force. M2 into A1. So this is your pseudo force. Are you getting? So I will apply a pseudo force. This is M2 into A1. Now let us calculate the time when just starts sleeping. So when just stops sleeping, at that point of time A2 will be 0. Just starts the sleeping. So A2 will be 0. So I can say, did you agree or not? Just starts the sleeping means, okay, so you see what we are saying, if this just starts the acceleration, so at that point of time, when just t is equals to t naught, I can say this relative acceleration is 0. So I can say at t is equals to t naught, relative acceleration with respect to just start sleeping, A2 is 0. Why? This is because this just starts sleeping. Just starts sleeping. So this is because this is just starts the sleeping, and that's why. So now if I equate the forces, acceleration is 0. So this means total force is equals to mass into acceleration. Acceleration is 0. So total force has to be balanced. So I can say Km2z plus in this direction M2A1 is equals to force in this direction AT naught. Time is T naught, so this will become AT naught. You write down, then we will go for the next page. You just copy this one. So So just copy and then we'll go for the next page, I think the font is coming very fine. Do you agree or not? Okay, good. Okay, so let us do, so if I slightly move this up, I can have something like this. Are you able to see? Yeah. Now see, so if I solve for T naught, so I will have T naught is K M2Z plus M2A1 divided by A. So this will be the time T naught. But now A1 is unknown, so I can solve for A1. So A1 is total force on this is Km2Z and mass of this is M1 and acceleration of this bar is A1. So I can write an equation for this. So on this object you see the force is Km2Z, mass is M1. So force is equals to mass into acceleration. I can solve for A1. So A1 is what? Km2Z divided by M1. If I plug the value here, so I will find T naught. So T naught is what? So T naught will be Km2Z. So let us take this 1 by A common. So this becomes Km2Z plus M2. And what is this? This is K. Did you have any mistake? I don't find so. So this is A1 is Km2Z divided by M1. So if I take common, so T naught will become 1 by A. So Km2Z is common. So if I take K M2Z common, so this will become 1 plus M2 by M1. Are you getting? So now I can further write. So this is M1 plus M2 into K into M2Z divided by A times M1. So this is the final value of a T naught. Now after this time both will have different acceleration. Even after this time, so this is the time. So if T is greater than T naught, basically both are sleeping. So both are sleeping. Are you getting? And this block, the upper block, this is going faster and this is going slower. So this has higher acceleration, this has a lower acceleration. So this will have a higher acceleration, and this will have a lower acceleration. Are you getting or not? So after this time both will have different acceleration. So this will have a different acceleration, this will have a different acceleration. Now for this one, this will have a basically constant acceleration, because on this you see the force that is acting is Km2Z. So what is the force this is acting? So you see here. So on this, if you see the force that is acting is Km2Z, that is constant. So M1 will basically have a constant acceleration. So M1 will have, so force is constant. So on this, what is the force? K times M2Z. So M1 will have a constant acceleration. So M1 will have, so let us write, will have constant acceleration. Are you getting or not? And what will be the value? Value is so simple. The value we have calculated, that is this value. So you see here, this value we have calculated somewhere. I think where we have calculated. So this one. So A1 is this one, this value. Did you agree or not? So this is the A1. So now this will have a value of, so A1 will be, so you see this value is Km2Z by M1. So Km2Z by M1. So this will have a constant acceleration. But for object 1 that is on the top, force is still acting as a into T. It will have a pseudo force. If I want to find the, with respect to what is the acceleration, so this will also have a pseudo force. M1 times, so this is the mass of this is basically M2. So M2 times A1, that is the A1 is nothing but so M2 times A1. And this will have a force, friction force, that is in the backward direction, K times M2 times Z. And now this has the acceleration A2 relative to A1. So this acceleration is a relative acceleration. So I can solve for A2. So you can solve for A2. So the force is AT minus Km2Z and minus M2. A1 is what? Km2Z by M1. So this is k m2z by m1. So this is the relative. So acceleration, if I plug the value of a1 here, I can have km2z by m1. So this will come out to this. Now the mass into acceleration. So mass is m2 and relative acceleration is a2. So I can find from here what is a2. So you see a2 will come. So you will have a at and 1 by m2 will come here. So this is 1 by m2. Are you getting or not? At minus km2z. If I take common, if I take km2z common, this will become 1 plus m2 by m1. So this is the acceleration. You see the relative. So the total acceleration of block 1 will be this plus a1. So total acceleration. So let me take another page. This becomes slightly lengthy. So total acceleration of block 1. Total acceleration of block 1. This will be a1 plus a2 because a2 is the relative acceleration. So a1 is what? a1 is, you see, km2z by m1. So k m2z by m1 plus this value a2. Are you getting? So a2 is 1 by m2 at minus k m2z 1 plus m1 by m2. So 1 plus m2 by m1. Are you getting? So this is the final acceleration of block 2. Now are you getting or not? We have not done anything. So this acceleration, if you see, this is a function of time. So you see here, if time increases, acceleration of block, so this is the total acceleration of block 1. That is the bar over this Planck. Now you see, the third part of the question says you plot these graphs. So what we can do is we can try to plot. So let us say this is my x-axis, y-axis, and this is my x-axis. So this is time axis, this is acceleration axis. If you see, before t is equals to t naught, both blocks are going with the same acceleration. You see, both blocks will have acceleration, same acceleration. If you see this value, the first page. If you see the first page, both will have same acceleration, that is at by m1 plus m2. So both will have same acceleration, and that value is at by m1 plus m2. So that is same, both will have same acceleration. Now this acceleration will depend upon time. So before this time, this acceleration, if increase t, this acceleration will increase. So you have a linear graph, and this graph will maximum value will have this value at t naught, a t naught by m1 plus m2. So at this point you will have a t naught by m1 plus m2. Are you getting or not? So this both will have, so block 1 as well as, so let us call this omega 1 for block 1, omega 2 for block 2, both will have same acceleration. But after this time, you see, what is the, this is after greater than t naught. So if t is greater than t naught, we have already derived. Now the block 2 moves with a constant acceleration. So you see, so block 2 moves with a constant acceleration km2z by m1. Are you getting or not? So the acceleration of block 2, for block 1, that is the lower block. So lower block have a constant acceleration km2z by m1. So this is the lower block, this have a constant acceleration. So after this time, for lower block I can plot something like this. So this is a constant acceleration. So this is for lower block, that is a, let us call this is a lower block. So lower block is basically block 1 or 2. Let me see. So this is lower block is 1. So you see here. So lower block is 1 here. So you see lower block is 1. So this is lower block is 1. So this is for 1. What about for upper block? If you see upper block, again acceleration is given by this function. You see k m1 m2 by z by m1 plus 1 by m2, this function. But this function depends upon time. So this is a linear function of time. So this upper block has a acceleration. There is a linear function of time. This is a linear. So I can plot this one. So this goes, so it will have a different acceleration. It has a more acceleration previous than. So now the slope will increase So this will go something like this. So this is for upper block, block 2. So this is upper block. Are you getting or not? Let us copy this one. This problem is quite good problem in the sense that it covers a large number of concepts. You see, it covers a concept of friction. Let me explain once again what we have done, all the things. I have two blocks. They are kept together. Initially, if I apply a force on the top block, it's very obvious if this force is very low, both blocks will move together because friction is more than two blocks. Are you getting or not? If the applied force is greater than the friction, then both blocks will move separately. If both blocks are moving separately, then upper block will slip over the down block. So upper block will have more acceleration than the down block. Now, so I can analyze the motion by by taking the use of pseudo force. I can assume the upper block has acceleration a2 with respect to lower block that already has acceleration a1. Now I can solve this equation. To find T0, what I will do is, I will consider the time when the force is F is equals to a T0, just slipping a starts. This means, if just slipping a starts, I can assume this block, that the upper block, this block will have just a zero acceleration when just slipping a starts. So if I use that, I can solve for T0. Are you getting or not? If I solve for T0 and if I plug all these values and if I try to make a diagram, I will get the same kind of diagram. You see, the block basically becomes, after some time, block 1 becomes a constant acceleration. So this is all about this problem, you know. We'll discuss the next problem. Somebody is calling me. Okay.